Okay, if you're joining us from home, please pause the video to write down the problems for your Bell worksheet, and then come back to me when you're finished with them, and I'll have the answers for you. Okay, so hopefully the first thing that you did is draw a picture. When you're not given a picture, the best mathematical strategy that you have is to draw an image of what the verbiage is telling you. All right, so let's pick out some important information. So the first part of the problem says find the value of x and kl. So that's exactly what we're going to be looking for. That's what we're going to try and find in the end. Okay, my next important piece of information says that k is between j and l. All right, so I'm going to draw myself a little picture. I have j and l, and k is somewhere in between. It doesn't say anything about a midpoint, so I'm just going to make it look so like it's not in the middle. It doesn't mention it. Okay, so then it goes on to say that jk equals 2x. Then it says that KL equals x plus 2. And then it says that JL, the whole thing, is equal to 5x minus 10. Okay, so with our with our segment addition formula, what we learned yesterday is that if I have two little segments, that when I add them together, I get the value of the big segment. Okay, so in that little example right there, 3 plus 2 is 5. Well, this one with the x's in is no different. If I add these two little segments together, this one plus this one, it should equal this. All right, so there's your equation. Set it up as 2x plus x plus 2 equals 5x minus 10. All right, here we go. On my left side of my equation, I've got a couple of like terms here. 2x plus another x is going to give me 3x plus 2 equals 5x minus 10. Okay, I'm going to do some mental math here because I'm running out of space. So I want to get all my x's on the left. So on my right side of my equation line, I have a positive 5x. So if I subtract 5x from both sides, that will make this go away, and then if I subtract 3x minus 5x over here on the left, I'm going to get a negative 2x. Okay? Then I'm looking at my numbers. I want to move my positive 2 or get rid of my positive 2 on the left side, so I'm going to have to subtract 2 from both sides. So when I subtract 2 from my left side, this will go away. When I subtract 2 from my right side, that will give me negative 12. Now I have to divide both sides by negative 2, so I have x is equal to 6. So I have done the first part of my problem. I have found x, but I still need to find KL. So KL is from here to here, so I'm going to take my value of x, which is 6, and add 2 to that, and that gives me 8. So I have x equals 6, KL equals 8. Okay, next one. In the given diagram, y is the midpoint. Y is the midpoint. That's very important information in this problem. So I'm going to go ahead and label that on my diagram. Okay, let's talk about what that means if y is the midpoint. If y is smack dab in the middle of that line segment, that means that, well, let's look at another little example here. Let's say that this whole line segment is 4, and I have a middle point, which means that this line segment and this line segment have to be the same length, which of course means that this would be 2 and this would be 2, because they have to be equal to each other. Well, in our example above here, where I have y as the midpoint of that line segment, the same concept has to apply. If this is the midpoint, then the left side has to be equal to the right side. So we're going to set up our equation just like that. I'm going to have 2 times x plus 4 is equal to 3x minus 3. All right, so with this particular problem, I have to distribute. That's going to give me 2x plus 8 equals 3x minus 3. Okay, here we go with the mental math again. So I need my x's over here. All right, so I got to get rid of that 3x on the right side of the line. Since it's a positive 3x, I'm going to subtract 3x from both sides. And in doing so, if I subtract 3x from here, that is going to make that equal 0. If I subtract 3x from here, that is going to give me negative 1x. Okay? Then I'm going to move my 8, my plus 8 I have to get rid of that. So I'm going to subtract 8 from both sides. So in doing so, that is going to get rid of that. And when I subtract 8 from negative 3 on the right, that's going to give me negative 11. And when I divide both sides by negative 1, I'm going to get x equals 11. So let's see if that's what the problem asked me to do. It says find x. Did that. Then I have to find the length of xz. All right. So if x is 11, I have to plug 11 in for x. So that's going to be 2 times 15, which is, because I have to do the parentheses first. So 11 plus 4 is 15 times 2, which is 30. Then I have to plug 11 in for here, for this x. So 3 times 11 is 33 minus 3, which is also 30. And if both pieces are equal and they're 30 each, which they should be because y is the midpoint, 30 plus 30 will give me my whole length, which is 60. So xz equals 60. Okay, here we go. Skipping the homework. Okay, in your table of contents, pause it and fill in your notebook, please. In your actual notebook page, please write your objective, the page number, and pause it while you're doing that, please. Okay, yesterday we learned that the midpoint is the middle point of a line segment. Okay, we also learned that I could mark my line segments with little hash marks like this to indicate that they are equal to each other. And if this line segment was labeled ABC, I could say that AB, line segment AB, is congruent to line segment BC. Okay, so that's what we learned yesterday. Today we're going to learn how to find the midpoint of a line segment if I am given 2 coordinates on an x and y coordinate plane. So there's the x coordinate, here's the y, okay, and I'm going to be given 2 different coordinate points, the endpoints of the line segment, and I'm going to figure out how to find the midpoint. All right, so to find the midpoint of a horizontal line, okay, notice there's no vertical change. I'm only going in the horizontal direction, so I'm not really so much concerned about my y coordinates. I am only concerned with the x coordinates of my xy point. If I want to find the halfway point between those 2 points, I simply need to add the 2 x coordinates and divide by 2. Okay, and we will always be divided by 2 because I'm trying to find the halfway point, the middle point. I want to cut it in half. All right, so negative 3 plus 5 is 2 divided by 2, which is 1. Now keep in mind, I'm only talking about my x coordinates right here. So this means that when x is 1, I'm going to go ahead and put a point up on that line. All right, I'm going to do the same exact thing for the y, for a vertical line, except this time I'm only going to be concerned with the y coordinates because there is only a vertical change here. All right, so I'm going to do the same thing. I want to find the halfway point, so I'm going to add my y coordinates, 3 plus 0, and divide it by 2, which gives me 3 halves. And if you want to do a decimal, that's perfectly okay too. In fact, if you were actually graphing points, decimals are more convenient. For example, if I want to find 1.5 on my line here, it's easier to do that, go up 1 and then half again, and then here's my middle point right there, rather than try to graph for 3 halves. Okay, so here we go. Now I'm going to try and find the midpoint of a diagonal line. So please take a moment to pause the video and write down those steps. Okay, so I'm going to actually find the midpoint of this line segment now. So according to the steps, I have to first add my x coordinates and cut them in half. That's what find the midpoint means. So I'm going to take my x coordinates, which are -3 and 8, and add them, and divide by 2, which will give me 5/2, or if you're using the decimal, that would be 2.5. So the x coordinate of my midpoint is 2.5. All right, now I have to do the same thing for the y coordinate. So find the midpoint of the y coordinates. So I'm going to take the y coordinates now, add them, 5 plus -1 all over 2, which gives me 4/2, which reduces to 2. So the y coordinate of my midpoint is 2. Here's my x, here's my y. All right, so if I go over here and look at my graph, this says when x is 2.5, y is 2. So it looks like we nailed it. All right, next example. Oh, not an example, sorry. Here is your actual formula. So all this says is if I want to find the midpoint of any line segment, it actually works for horizontal and vertical lines also. All I have to do is add that two x coordinates, the x1 and the x2, which is shown here, the x1 and the x2, and cut it in half. And then I have to add the two y coordinates, the y1 and the y2, and then cut those in half, and I'll find my midpoint. Okay, so first example, find the midpoint of the line segment with the given endpoints. Okay, so same thing. Take your x coordinates and add them and cut it in half. So my x coordinate is going to be 1/2. Then take the y coordinates and add them, cut them in half. So my y coordinate is 3/2. Again, if you were graphing, you would want a decimal version of that. So you could write that as 0.5 and 3.5. Okay, try that example on your own. Please pause the video. Okay, so I'm going to strongly encourage you to try and do some mental math here. So I can easily in my head add 2 plus 1, which is 3, divided by 2, which is 3/2. 4 plus a -3 is the same as 4 minus 3, which is 1, divided by 2, which is 1/2, and I'm done. Okay, pause the video and try to do some mental math in your head to find the midpoints of each of those segments of the triangle, and then graph your points and make sure that you did it correctly. And that's the end of today's lesson. Hope I see you tomorrow.